Alright, at this point you should have watched the um, metamorphosis. That was kind of a weird video, but I guess it was a good introduction of what a function is and the idea of a function, so that worked. Alright, so we have a key topic. Today we're going to be identifying functions. Okay, and identifying functions is about determining if a graph or table represents a function. Okay. Come on, dude. Pencil's going crazy. Okay. Don't know what those are, but that's okay. Alright, so before we do anything with the function of identifying it, we first have to define what is a function. A function is a relationship. Woo! Look at my pen. It's crazy. Alright, I'm going to pause so I can get this back into action. Alright, I think I fixed the problem. A function is a relationship such that every input don't do it to me again. Such that every that's not good either. Input there we go, has exactly one output. Alright, so every input has exactly one output. Okay, 1 second. It's gonna look crazy. There we go. That kind of lines up now, except for the tops. But that's good. Pretend they do. Sorry, my pen is goofy today. Alright, we have our domain and our range that we're also going to define. Domain is a set of inputs or input values, and the range is the set of output values. Okay, so now we're actually going to move on to your table or your graph. So this is going to be our input. This is going to be our output. Why did I say exput? That was weird. Output. Okay, and this is like kind of our function machine. So if I input 1, I'm going to output 2. If I input 2, I'm going to output 3. If I input another 2, it also goes to 4. Then 3 goes to 5, and 4 goes to 6. Alright, so this function machine actually is not a function. Alright, it's right here that it becomes not a function, where 2 goes to 3 but also 2 goes to 4. Those inputs, 2, cannot have 2 different outputs. It has to have exactly 1. So if I input 2, it has to either go to 3 or it has to go to 4. It has to go exactly just 1 output. Okay? So here we go with our next one. Our next table. If I input a -2 and I get a 1, and then I input 0 and I get 0. I input 2 and I get 1. I input 3 and I get 1 and 5/10. And then I get 4 and I get 2. This is my input. I'll label that. This is my output. You might be thinking that it's not a function because of these ones on the bottom, but actually it is a function. That's because every input that we have has exactly one output. Alright, so even though there's a 1 here and a 1 here, it doesn't mean that any of these go to the same or a different one, including itself. So in this one, our domain, and make these weird brackets. It's -2, 0, 2, 3, and 4. So that's what we're inputting. Our range, we're going to list from least to greatest, is 0, 1, 1 and 5/10, and 2. We do not need to list the 1 twice. Okay? Alright, then we're going to be over here on your graphs, and we're going to make 4 sets of graphs. Alright, so in our graphs we're going to look at different types of looking graphs. So if I have this as a graph, and change my line size so it doesn't look weird. Just a line that looks like this. So if you could copy down a line that just goes diagonal from left to right. Alright, this type of graph is a function. Because if we look at the x-axis, usually the x-axis, this horizontal line, is our input. Every input on this x-axis has one output from the y, so that works. Okay, what about if we draw something called a parabola? Need to have arrows first off. Something that looks like this. We'll make an upside down U shape. Even though it's not straight lines, if we look back at this x-axis, does every point on the x-axis have exactly one point on the y? Well, it does. I know this looks like it goes straight down, but in fact it kind of goes out. Okay, so this is a function. Okay? Oh, sorry. Working on getting that fixed. Alright, then. Oh, come on, man. Moving things around now. Now, if we have a line, dark blue this time, that goes up and down, a vertical line. Now this vertical line, even though you might think it is a function, because it looks almost like this first one, this orange line I have up here, In fact, it's not, because if we look at it, this is only one value of x, and for this one value of x, there's a ton of y's. It's y equals 1, y equals 2, y equals 3 and 5/10, y equals 4 and 7/8. Things like that. It goes all the way up and down. So this is not a function. Not a function. Okay. And then our last example here, that you should also be copying these down. Let's make it purple. Okay, don't copy it down yet, because I have to fix it. But, is if we have a graph that looks like this. Is this a function? Well, if we look at it, right here on this x, there's only one y. It's right here. But if we pick any other point on this graph to the right, there is a point on top and there's a point on bottom. There's two outputs there. So that's not a function. Alright. And then we have our so what. What's important to understand about this? Remember your definition of a function. Whoa. Alright, for the rest of the class period, you'll be working on the back side of this frame and then put it in your unit organizer. Okay, bye. Have a good day.